So here are the two big ideas that make DNS scalable. The first idea is that if a name server cannot answer your query, they must direct you to another name server that can help. So as an analogy, if someone comes up and asks a TA a question, if the TA doesn't know the answer, they can't just say, I don't know, sorry, go home. Instead, the TA is going to direct you to someone else who can help. So if you ask a question and they don't know the answer, they must tell you somebody else who is able to help. So that's our first big idea. And the second big idea, to make sure that we're not stuck in any weird cycles and we can never find an answer, is to arrange the name servers in a tree hierarchy. And what this will do is it will allow name servers to redirect you down the tree until somebody can give you an answer. So let's see these two ideas in action. So here is the DNS hierarchy tree. And so in this tree, each box represents a name server. So this box is a name server. It's a computer on the internet answering DNS questions. This box is also a name server, and so is that one, so is that one. Now, what I've put in the boxes tells me what this name server is responsible for answering. So for example, the name server, which I've labeled google.com, is responsible for answering any of the questions that end in google.com. For example, what is the IP address of www.google.com? Ask this guy. And what's the IP address of mail.google.com? Ask this guy. And what's the IP address of eeks.berkeley.edu? You should ask that one. So the label tells us what each name server is responsible for answering. And the very top name server, the root, is able to answer for any domain that you ask. So each box is a name server, and the label tells us what they can answer. So for example, this box can answer eeks.berkeley.edu queries, but if you asked it for mail.google.com, it would not be able to help. So to be a little bit more precise, if you're curious, it's not something we talk about too much in this class, but if you're curious how exactly this works, you can think of each of the boxes as representing a zone of domains. It's like a piece of territory or a slice of pie. And when the name server thinks that slice is too big or it doesn't want to handle all of that zone, what it can do is delegate parts of the zone to somebody else. So it's like cutting off a little piece of the pie or a little piece of your territory and giving it to someone else. Now they have control over that zone. So for example, the berkeley.edu zone can answer all of the requests for UC Berkeley and all of the domains ending in berkeley.edu. And it's got a name server that's sitting on the internet that can answer those queries. And if Berkeley one day decides, I don't want to handle all of the www.berkeley.edu subdomains, there's just too many of them, then Berkeley could cut off a little slice and say, actually, ischool.berkeley.edu should handle their own subdomains. So anything ending in ischool.berkeley.edu is no longer my concern. I cut that piece of the pie off, and I give it to this School of Information organization, and they have to set up their own name server to answer those queries. So to be a bit more formal, this is what the hierarchy actually looks like.